Final exams, math count. Joseph scored 76, 88, 96, and 98 on his 4 chapter tests this grading period. If the final exam will count twice as much as each of these chapter tests, and the 4 tests in the final exam are only items contributing to the period's grade, what is the minimum number score that Joseph must earn on the final to receive an average of 94? Receive your answer as a decimal to the nearest tenth. Okay, so we know that the final exam will count twice as much as each of the chapter tests. But we don't know what is the minimum number score. So we could just let that equal, let number score equal x. That's a variable. So 76 plus 88 plus 98 plus 96, and since we need 2 x's, so 2x, because it's double the value, divided by 6 is equal to 94. So to simplify this, we can multiply a 6 on either side of the equation. 6 times 94 is equal to 564. On the left side, this 6 will be canceled out, and we could just, right now, we could just add these 4 numbers. So 76 plus 88, that gives us 164 plus 98, that gives us 262, and then plus 96, which is 358. So we know that 358 plus 2x is equal to 564. Now we're trying to isolate x on one side. So we can subtract 358 on either side of the equation. This subtracted by 358 gives us 206. So x is going to be 206 divided by 2, which is 103. So how much does he have to earn to have a final average of 94? That would be 103. The final exam scores earned by the 16 students in Joseph's class are as follows: 80, 79, 96, 93, 94, 92, 88, 87, 90, 81, 83, 82, 89, 99, 91, 73. What is the positive difference between the median of these scores, average arithmetic mean, and the average arithmetic mean of these scores? Express your answer as a decimal to the nearest hundredth. So we're trying to find the difference between the median and the average. So we need to first find each the median and the average. So we know how to find the median, right? That would be the middle number when we rank it from least to greatest or greatest to least. I'm going to do least to greatest. So reordering this, we're going to have 73, 79, 81, 82. So we use 73, 79, 81, 82. Now we have 83. Oh, yep, in between this we have an 80. 83, then we have 87, 88, 89. Then we have 91, 92, 93, 94, 96, 99. Now we use all of these. So what's the median right here? Well, I would just count from both sides and I'd cross it out until I get to the middle, one number or two numbers. So these cancel out. And our median is 88. Now let's find the mean. Now the mean is basically adding all of these up and dividing it by 16. So you can do that and go ahead and add it and then divide by 16. And rounding to the nearest hundredth, we have 87.31 as our mean. Now we're going to subtract, and 88 is the larger one, so we're going to subtract 87.31 from 88.00. So this we get 9, right? Wait, so over here we got 10, 9, 6, 0, 0. So the positive difference between the median of these scores and the average would be 0.69 rounded to the nearest hundredth. In another one of Joseph's classes, the 14 eighth graders averaged 94 on the final exam, while the 12 seventh graders averaged 89 on the final exam. What was the average score for the entire class? Express your answer as a decimal to the nearest hundredth. So we would, the sum of the scores that the eighth graders earned was 94 times 14. That equals 1,316. And the total sum of the 12 seventh graders would be 89 times 12, which, would also be 1,080 minus 12, and that equals 1,068. So now we can take 1,316, add that with 1,068, and we get 2,384. Now we divide this by the sum of 14 and 12, and that gives us 28, right? And we will get about 91.69. So to the nearest hundredth, that would be 91.69.